Okay, so let us start the today's session. Okay, in the last session, okay, we have gone through some of the points. Okay, why the air refrigeration is required. Okay, why the air refrigeration is required. Okay, so that we have seen. Okay, why air refrigeration is required, that we have already seen. Okay, now we will see the types of refrigeration systems, okay, which are used in air refrigeration. Okay, see if I just tell you, okay, what we have seen in the previous session. Okay, what we have seen why air cooling is required. Okay, and what are the advantages that you will get by using aircraft refrigeration. Okay, so is that okay? We have covered this, all of you? Yes, have we covered this topic? Why
Yes, sir.
aircraft cooling is required? Why, what are the advantages of aircraft refrigeration, that we have seen in the last lecture. Okay, now in this lecture, okay, we will see the simple air cooling systems. Okay, we will basically see the types of air refrigeration systems. Okay, so these air refrigeration systems, okay, they are used in air cooling. Okay, what is the purpose to use them? Is to cool the air. Okay, so the air refrigeration system, okay, we will use for air cooling. Okay, so what is the reason for which we are using? It has been used for air cooling, right? It is used for air cooling, right? Is that okay? Yes, it is used for air cooling, right? Now see, in that we will first start with the simple air cooling system. Okay, simple air cooling system. Okay, then we will have simple air evaporative system. Okay, so this is the additional word, okay, which I'm using. See, this is simple air cooling system. Okay, second is simple air evaporative cooling system. Okay, the third is bootstrap air cooling system. Okay, and again in bootstrap I will add evaporative. Okay, so it will give rise to one more system. Then we have reduced ambient air cooling system and regenerative air cooling system. Okay, so what is expected for all these is you should be able to draw PV and TS diagram. Okay, we should be able to draw PV and TS diagram, right? So now let us start with this. Okay, now we will start first with, okay, we will start now with first, okay, that is simple air cooling system. Okay, we will start now with the simple air cooling system. Okay, so let us see the schematic diagram for the simple air cooling system. Can you see the diagram, all of you? Yes, are you able to see the diagram now? Yes, can you see the diagram?
Yes, sir. Yes, sir.
Now
Yes,
see
yes.
what we need to understand from this diagram. Okay, you might feel this diagram to be a very complicated diagram. Okay, but it is not the case. Okay, you can see this is the ambient air. Okay, see the simple air cooling system. Okay, where it is used, it is used in aircraft. It is used in aircraft, and in aircraft, for what purpose it is used? It is used for the aircraft refrigeration. Okay, so this simple air cooling system, it is used in aircraft refrigeration system, right? So see, this is the schematic diagram, okay, which I shown to you. Okay, now let us see here. Okay, all of you see here. Okay, see, this is the ambient air, okay, which is coming. Okay, now this ambient air, okay, I will indicate by point number 1. Okay, so point number 1, it is nothing but ambient air. Okay, so ambient air, it is atmospheric air which is coming. This ambient air, it is rammed. Okay, what is the meaning of rammed? Its pressure is increasing. Okay, so this rammed air, see, this is the initial air or ambient air. Okay, this initial air, okay, when it is rammed, okay, that rammed air, it is supplied to the compressor. All of you see, this is the initial condition. This is the initial condition. Let's say where pressure is P1. Okay, now the ambient air, when it is rammed, okay, we will get it at point number 2. Okay, where pressure is P2. Okay, where pressure is P2. Okay, so when it is rammed, what happens? We will get the value of P2 which is greater than P1. Okay, so during ramming, what happens is its pressure increases. During ramming, its pressure increases. So what happen is, okay, this is ambient air. Okay, when it undergoes ramming process, what happens? Its pressure increases, and obviously when pressure increases, obviously its temperature also increases. So we will get T2 greater than T1, right? We'll get T2 greater than T1. So the air which is at a condition 1, okay, we will ram it. Okay, so when it rammed, what happened? Okay, after it is rammed, okay, it is indicated by point 2. Okay, it is indicated by point 2, where we will get the pressure P2 and temperature T2. Okay, so obviously P2 is greater than P1 and T2 is greater than T1. Now see, once it is ramped, okay, what we'll do, we will supply it to the compressor. You can see the diagram for the compressor, right? After that, we will supply that to the compressor. Okay, so now what happens when we supply that to the compressor, right? This is basically the main compressor. This is a compressor, right? So when we supply it to the compressor, right, obviously the purpose of the compressor is to increase the pressure, right? What is the purpose of the compressor? Is to increase the pressure. Okay, so 2 is the inlet to the compressor. Okay, let us call this point. Let us call this point as a 3. So 3 is the exit to the compressor. Okay, 2 is the inlet to the compressor. 3 is the exit to the compressor. Okay, now what we'll get? We will get pressure at the exit of the compressor. Okay, let that pressure be P3. It is greater than P2. Okay, all of you, pressure at point number 3, it is greater than pressure at point number 2 because it undergoes a compression process. Similarly, temperature at point number 3, we will get it as greater than temperature at point number 2. Sorry, temperature at point number 2, right? Because it is again a compression process, right? See, during 2 to 3, as you can see in the diagram, 2 is the inlet to the compressor, 3 is the outlet to the compressor. So during compression, what happens? Okay, pressure increases as well as temperature increases, right? Now see, what is done here is, okay, whatever the air that is coming out of the compressor, okay, where it is supplied, you can see this air, it is supplied. Okay, I'm just tracing the path of the air. The air, it is supplied to the heat exchanger. See, this is the device. Okay, now the air is supplied to this heat exchanger. Okay, so you can see the passage of the air, how it is flowing. Okay, so air is flowing like this. Okay, now see, what is the purpose of the heat exchanger? So the purpose of the heat exchanger, okay, is to exchange the heat. Okay, what is the purpose of the heat exchanger? Is to exchange the heat. Purpose of the heat exchanger to exchange the heat. Okay, now what happens is, the air which is coming out of the compressor, we are supplying it to the heat exchanger. Okay, now you know that, okay, the air will be at a higher pressure and at a higher temperature. Okay, you can see this P3 is greater than P2. Similarly, T3 is greater than T2. Okay, so this high temperature air we will cool. Okay, the high temperature air we will cool it in a heat exchanger. Okay, so how that air will be get cooled? Okay, see, this air is going through this tube, right? You can see these tubes. Okay, so through this tube the air is flowing. Okay, and that air I need to cool. Okay, now how I should cool that air? Okay, so as to cool that air, all of you can see here. Okay, so as to cool that air, what we have? Yes, what we have? Yes, so as to cool that air, what we have, all of you? Yes, can anybody let me know? Yes, so as to cool that air, what we have, all of you here? See how the air gets cooled. Now see how this cooling is achieved. See, can you see here about the air which is coming inside? Okay, so whatever the air that is coming here, where it is supplied, see that rammed air, it is supplied to where? It is supplied to the heat exchanger. Is that okay? So this air, okay, it is supplied to where? Heat exchanger. Through what happens? Through this end, cold air is coming. You can see that cold air is coming inside. So cold air, it is coming inside. Okay, so cold air, it is coming here inside. Okay, now through this end, what is happening? Heat air is going. Okay, or hot air is going. Hot air is going inside, right? Hot air is going inside. Okay, so through the tube, hot air is going, okay, and on those tubes cold air is flowing, right? Is that okay? Yeah, is that okay or not? Let me know. Through the tube hot air is going, okay, and on the tube cold air is flowing. Yeah, is that okay? Yes. Yes, is that
Okay,
clear?
sir.
So what happens when this hot air, okay, if you want, I'll just clear it, clear all the annotations. Okay, I'll just clear all the little annotations. You can see now. Okay, now see here what happening is hot air is flowing inside, right? Hot air, okay, it will go through this end. Okay, from here hot air is flowing through the tubes. Okay, it will flow through a tube like this, right? And on those tubes, okay, the cold air is flowing. On those tubes cold air is flowing, right? So what happens when this hot air comes in contact with the cold air? You can see on these tubes what is happening, the cold air is flowing. Okay, on these tubes cold air is flowing. Okay, now what happens when this hot air exchanges the heat with the cold air? What happens, this hot air will come out of the heat exchanger as a cold air. Okay, it gets cooled. Okay, that is the only purpose of the heat exchanger, right? So hot air, okay, at the exit of the heat exchanger turn out to be cold air. Okay, now what happens with the cold air? The cold air, okay, it turns out to be the hot air. Okay, try to understand. See, purpose of the heat exchanger, purpose of the heat exchanger is to exchange the heat. Okay, what is the purpose of the heat exchanger? Is to exchange the heat. So what happens when hot fluid exchanges the heat with cold fluid? It becomes cold. When hot fluid exchanges the heat with cold fluid, it becomes cold. While cold fluid, when exchanges the heat with hot fluid, it becomes hot, right? So what happens when hot air, it comes in contact with this cold air, okay, this hot air becomes cold, okay, and this cold air becomes hot, right? Is that okay or not? Let me know. Yes.
Yes.
Okay, now see what is happening. See, now whatever the cold air, okay, that is coming out, okay, whatever the cold air that is coming out through the heat exchanger, we are supplying it to the turbine. You can see this, where it is supplied, it is supplied to the turbine, right? It is supplied to the turbine. Now see, when this cold air flows on the blades of the turbine, okay, when it flows on the blades of the turbine, what happens in turbine? All of you know that in turbine what happens? In turbine expansion occurs. Okay, in turbine what happens? In turbine expansion occurs. Okay, so what happens during expansion? Okay, what happens during expansion? Okay, temperature drops down. Okay, temperature drops down. Okay, so you will get temperature here. See, we have started with this point. This is a point number one. This is point number two. Okay, this is point number two. Okay, this is point number three. Okay, this was point number four we have plotted. Okay, four. Okay, and this is point number five. So when this cold air is flown on the blades of the turbine, what happens? It expands. Okay, it expands. As a result, we get temperature at point number 5 less than temperature at point number 4, right? Because during expansion what happens? Temperature decreases. So you will get temperature at point number 1 less than temperature at point number 4. Okay, because see here see, let us talk about it in terms of temperature. Here temperature was T1, here temperature is T2. Okay, but this T2 is greater than T1 because it is rammed. Okay, similarly here temperature is T3, but this T3 is greater than T2 because it is compressed, right? Now when this T3 come here, it becomes T4. Okay, here what you will get? You will get T4 less than T3 because it is cooled. See, at the inlet to the heat exchanger, temperature was T3. At the exit of the heat exchanger, temperature is T4. Okay, and see why we are using this heat exchanger? Because we need to cool it. We want to cool it, so we should get temperature T4 less than T3, right? Similarly, when it is passed through turbine, okay, again T4 drops to T5, okay, so we'll get T5 less than T4, right? Now see, when this air is flowed on the blades of the turbine, what happens? Blades of the turbine starts rotating, they will start to rotate, okay, they will start to rotate, okay, and when they will start to rotate, what will happen? On the same shaft we have mounted a cooling fan. As you can see, we have mounted a cooling fan, okay. So on the, so see the blades, when this cold air is flown on the blades of the turbine, blades of the turbine starts rotating, okay. And you can observe that, okay, the turbine is mounted on a shaft, okay, where on the same shaft we have mounted a cooling air fan, okay. So when this turbine starts rotating, okay, shaft start rotating, and when shaft start rotating, okay, obviously this fan start rotating, okay. And what this fan is doing, it is drawing the hot air from the heat exchanger, you can see, because see, this hot air is to be taken out, okay, and it will not be done automatically, okay. So for that, what we are using a fan, so which can draw the hot air, okay, back to the atmosphere, right, which can draw the hot air back to the atmosphere, right? Now see, here also same we have seen the compressor here, okay. For to run a compressor we require a power, okay. So what we are doing, out of some compressed air, okay, some compressed air we will supply into the combustion chamber, okay, where we will supply the heat, okay, we will supply the heat, okay. See, some part of the uh, compressed air we will supply into the combustion chamber, where we will add the heat, okay, and that heat is further supplied to the turbine, okay. Now what will happen? See, turbine is a power producing device, so when turbine will start rotating, obviously shaft will start rotating, okay, and this shaft, it is further coupled to compressor. See, compressor is power consuming device, turbine is power producing device, okay, both are mounted on a same shaft, okay. So what we are doing, okay, we are running a compressor by using a turbine, okay. So out of some compressed air we are supplying it to the turbine, okay, and that is basically driving the compressor, okay. So no external work input is to be supplied, okay. Same whatever compressed air that is coming out of the compressor, same we are utilizing so as to run a turbine, okay. And the turbine and compressor, they are mounted on the same shaft, okay. So turbine, whatever the power that is produced by the turbine, okay, same will be consumed by the compressor, right? So this is one more part, right? This is one more part, okay. And similar happen here, okay. This is a cooling turbine. So whatever the power that is produced by the cooling turbine is utilized so as to run a cooling fan, okay, which draws the air from the heat exchanger, okay. Now see, here it is important term. Now see, I will mention here, okay, this is T5 is less than T4. Now see, where it is supplied, the air which is coming out of the turbine, it is supplied to where? It is supplied to the cabin, okay. This air is supplied, see this arrow indicates that air to cabin, okay. So here what I will do, okay, I will simply draw this, okay, I will simply draw cabin here, okay. Just give me a minute. Okay, so what I will do, okay, here I will mark a cabin, right? Here I will mark a cabin. So see here, all of you, okay, here somewhere here I will mark a cabin, okay. Let us see, this is a cabin, this is basically the cabin, right? So you can see five is the inlet to the cabin, right? Because see, once it is getting out of the turbine, where we are supplying it to the cabin, okay. So 5 is outlet of the turbine, or it is inlet to the cabin, okay. And 6 is what? 6 is the exit of the cabin, right? 6 is nothing but the exit of the cabin. Now see what happens during the passage of the flow, during the passage through the cabin, okay, during the passage through the cabin, what happens is temperature increases. This is very important, because when you supply this cooled air, when you supply this cooled air into the cabin, what happens? What happens? This cooled air will abstract the heat from the cabin, okay. This cooled air will abstract heat from the cabin, As a result, what happened? Cabin gets cooled. Okay, see, this is a what is the temperature of the air? It is T5. Temperature of the air is T5. Okay, and when you supply this air which is at a temperature T5 into the cabin, what will happen? That air abstract the heat from the cabin. Okay, as a result, what happened? Temperature of the cabin gets decreased. That means it gets cooled. Temperature of the cabin gets cooled. But what happens with the temperature of the air? It gets increases. Okay, so we'll get T6 greater than T5. Okay, we'll get the value of T6 greater than T5. See, see all of you, the temperature of the air gets increased. That's the reason why temperature of the cabin gets decreased, because this air will abstract the heat from the cabin. Okay, as a result, its temperature increases to T6. Okay, but when heat is abstracted from the cabin, what happens with the cabin? Its temperature decreases. Okay, so in the cabin only, okay, we are getting a refrigerating effect. What we are getting in the cabin? We are getting the refrigerating effect in the cabin only. Okay, so we get the refrigerating effect in cabin only. Yeah, is that okay with the diagram? Yes. Yes, all of you. Yes, let me know, is that okay with the diagram?
Yes.
Yes, all of you also can respond, is that okay?
Yes, sir.
Okay, now see, this is all about what we have seen is the PV and TS diagram, right? Now what we have seen is the PV and TS diagram, right? Now let us see, okay, about, let us see about what. See, this is about the schematic diagram. Now we need to see the PV and TS diagram. Okay, now let us start with the process. Okay, let us start with the every process. Okay, all of you pay the attention here. See, 1 to 2, can you see the process 1 to 2? See, one is the ambient condition. Okay, one is the ambient condition, as you can see. Okay, and two is the condition after ramming. Okay, so one is the ambient condition. Okay, so we will ram it. Okay, so we'll get the air at point number 2. Okay, so 1 to 2 is a ramming. So what happens during ramming? Its pressure increases. Okay, so all of you can see this point number 1. Okay, so point number 1, it's the ambient condition. This is the ambient condition, right? This is the ambient condition. Okay, this is nothing but the inlet condition. Okay, so from 1 to 2, what we are doing, we will be compressing it. Okay, so 1 to 2, it's a compression. Okay, so 1 to 2, it's a compression, right? So we will compress it. Okay, but this compression is isentropic, because see, which diagram we are seeing here is TS diagram. Okay, so this is a vertical line. So this vertical line indicates that, okay, we have the value of S1. Okay, just a minute, we have the value of S1 equal to S2. Okay, what value of S1 we have? Value of S1 we have equal to S2. Okay, S1 and S2, they are same, because it's a straight line, or it's a vertical line on a TS diagram. So during this ramming, what happens? Entropy remains constant. Okay, that means it's an adiabatic process. Okay, 1 to 2, when you talk about 1 to 2, it's isentropic or adiabatic. So 1 to 2, it's isentropic or adiabatic, right? Now see, there are two options. See, 1 to 2, this 1 to 2 process, as you can see, this 1 to 2, it's the ideal process. This is the ideal process, right? 1 to 2, it's the ideal process, or you can call this as the isentropic process. While 1 to 2 dash, okay, it's the actual process. It's the actual process. Okay, 1 to 2 dash, it's the actual process. Okay, so this is ideal. 1 to 2 is ideal. 1 to 2 dash, it's the actual. Okay, see, what do you mean by this 1 to 2? 1 to 2, it's the ideal process, means that you have 100% efficiency. Okay, so during this ramming, we have 100% efficiency. Okay, so that is 1 to 2. See, what is 1 to 2? Okay, that is ideal ramming. 1 to 2, it's the ideal ramming process. And 1 to 2 dash, it's the actual ramming process. Yeah, is that okay? Yeah, let me know. Okay, is that okay with this one? Yes, I'm asking to everyone, is that okay? Yes, am I audible?
Yes, sir.
Okay. Now see, this is 1 to 2 or 1 to 2 dash. Okay. Now let us see the next process. Okay, 2 to 3. You can see this 2 to 3. 2 to 3. It is done in compressor. 2 to 3. It is done in compressor. Okay. So let us try to plot it. Okay. See, this is 2 dash. Okay. From actual, I will start. This is the point 2 dash. So from point 2 dash to 3. Okay. So see this 2 dash. 2 dash. It is nothing but inlet to the compressor. See, this is inlet to the compressor. This 3 is the exit to the compressor. Okay, now as you can observe here, okay, one, see this 2 dash to 3, this process 2 dash to 3, it's the ideal process. Again, it's the ideal compression. You can call this as the ideal compression or isentropic compression, or you can call this as the adiabatic compression. Okay, this is adiabatic compression. Okay, but when you talk about this, okay, it's an actual compression. This is a actual compression. This is the actual compression, because see what happens. Okay, you may expect the temperature to rise up to T3. Okay, you may expect that temperature may rise up to T3 during ideal compression. Okay, but in actual, it rises to T3 dash. You can see the purpose of the compressor is to only compress, not to increase the temperature. Okay, so what happens ideally, its temperature increases to T3. Okay, but actually its temperature increases to how much? T3 dash. Okay, and that is irreversibility, right? This is a irreversibility. So this 2 dash to 3 is a irreversible process. You can call this as irreversible process because it's a actual and all actual processes are irreversible. All actual processes are irreversible processes, right? While ideal processes, all processes are reversible process, right? All ideal processes, you can call them as ideal. Okay, or it's isentropic, or it's adiabatic, or it's a reversible. Okay, that means this process, it is having 100% efficiency, right? See this 2 dash to 3, this 2 dash to 3, it is having 100% efficiency. Okay, now what is about 2 dash to 3 dash? See this 2 dash to 3 dash, it is having efficiency less than 100%. Okay, efficiency is less than 100%. Okay, here efficiency is equal to 100%. You can see 100, it's a straight line, it's a isentropic, it's a adiabatic, it's a reversible process. Okay, so here it's a straight line, means you have 100% efficiency. If you can see this dotted line, okay, it's the actual process, and all actual processes are irreversible processes. Okay, where you will get efficiency less than 100%. Okay, because see, because when during compression, okay, you may expect that temperature should increase to T3. Okay, you may expect that temperature to increase by T3, but in actual it increases to T3 dash, right? In actual it increases to T3 dash. That is the reason why compressor in actual consumes more power than ideal. Okay, that is the reason why compressor in actual consumes more power than ideal. Okay, so you can see this. Ideally it may require only T3 2 dash to 3. See, all of you, compressor ideally may require 2 dash to 3, but in actual it requires 2 dash to 3 dash. Okay, so you can see this 2 dash to 3 dash, it is greater as compared to 2 dash to 3. Okay, that's why compressor always consume more power in actual condition as compared to the ideal condition. Yeah, is that okay? Yes, is that okay with this one? Let me know. Yes.
Okay.
Yeah, now see, we have finished with the 2 to 3, right? 2 to 3, right? Next, 3 is the exit of the compressor, and exit of the compressor is inlet to the heat exchanger. You can see this. See, 3 is the exit of the compressor, and that is nothing but inlet to the heat exchanger. Okay, so inlet to the heat exchanger is 3, as you can see, and exit to the heat exchanger is 4, right? Exit to the heat exchanger is 4, right? Now what happens in heat exchanger? What happens in the heat exchanger? Hot air gets cooled to cold air. Okay, hot air becomes cold. Okay, but you know that in heat exchanger pressure is constant. Okay, because throughout the heat exchange process the pressure is constant. Okay, so see all of you. Okay, so this is the exit of the compressor, point number 3. Okay, this 3 dash, 3 dash, this is the exit of the compressor. Okay, so from the exit of the compressor it is nothing but inlet to the heat exchanger, right? Exit of the compressor, it is nothing but inlet to the heat exchanger, right? So 3 is the inlet to the heat exchanger. So from that what happens? Okay, the hot air gets cooled. Okay, hot air gets cooled at a constant pressure. So if you observe pressure at point number 3, it is same as pressure at point number 4. At any point on this line pressure is constant. At 3 dash we have hot air. Okay, at point number 4, okay, we got cold air, we got cold air. Okay, and this process 3 dash to 4, it is conducted in a heat exchanger. You can see this process 3 to 4 or 3 dash to 4. You can see this 3 is the inlet to the heat exchanger, 4 is the exit of the heat exchanger. Okay, so this process 3 to 4, it is done in heat exchanger. As a result hot air gets converted to cold air, right? Hot air gets converted to cold air, right? Yeah, so from 3 dash to 4, okay, the hot air exchanges the heat, so it becomes cold. So at point number 4 we are getting cold air. Yeah, okay, so obviously, okay, as you can see, as the air gets cooled, what happens? What was the initial temperature? It is T3 dash. This was the initial temperature. Now what final temperature we got? We got T4. Okay, obviously you can observe that T4 is less than T3 dash, right? We got the value of T4 which is less than T3 dash. Okay, that means this hot air gets cooled to cold air. Okay, so now we are at a point number 4. Now we are at a point number 4, right? Now see, once it is getting out of the heat exchanger, we will supply to what? We will supply it to the blades of the turbine. As you can see, we will supply it to the blades of the turbine. So 4 is the exit of the heat exchanger. After that we will supply it to the blades of the turbine. So blades of the turbine will start rotating. Okay, and in turbine what happens? Expansion occurs. As a result, okay, the temperature of the air gets decreased to T5. Okay, so 4 is the inlet to the turbine, 5 is the exit to the turbine. Okay, so you can see this 4 is the inlet to the turbine and 5 is the exit of the turbine. Okay, so during 4 to 5 what happens? Expansion occurs. See, it is exactly reverse of compression. See here 2 dash to 3, it's a compression. 4 to 5, it's the expansion. Okay, so this air get expanded where? It is get expanded in a turbine. Okay, so here it gets expanded in a turbine. Okay, so this expansion occurs in a turbine. Okay, now you can see this. Okay, this 4 to 5, 4 to 5, it's expansion. Okay, again I told you, okay, this is ideal expansion. As like compression, it's a ideal. Okay, or you can also call this as isentropic. Okay, because the entropy is constant. You can also call this as adiabatic. Okay, or you can call this as a reversible, or you can call this as a reversible. Okay, it is having one and same meaning. Okay, that means here you will get efficiency 100%. Okay, you will get efficiency 100% here, right? Now but when we talk about this dotted color, okay, dotted color, okay, this dotted color, it's the actual, this is the actual expansion. Okay, so what happens in actual expansion? Okay, you will get efficiency always less than 100%, right? We'll get efficiency always less than 100% because, okay, power producing devices consume, sorry, power produces devices produces always less power in actual condition as compared to the ideal condition. Okay, you may expect this turbine to produce 50 kilowatt power in ideal conditions, but in actual conditions it always produces less power. Okay, it might produces 30 kilowatt. Okay, ideally you may expect 50 kilowatt, but in actually it is producing only 30 kilowatt. Okay, that's because actual efficiency, it is always less as compared to the ideal efficiency, right? So this is what the expansion which occurs in a turbine. So you can see here, okay, all of you see here, actually we are expecting more. Okay, so you can see this length T4 minus T4 and T5, 4 to 5, that is ideal. 4 to 5, that is ideal. It is greater as compared to 4 to 5 dash. Okay, because 4 to 5 dash is actual. So 4 to 5 dash actual, it is less as compared to 4 to 5, which is ideal. Yeah, is that okay with this one? Yes, is that okay? Yeah, is that okay with this one?
Yes.
Yeah, is there any doubt you're facing with it? Yes. Yes. Okay, so now the air is coming out of the turbine. Now once it is getting out of the turbine, where we are supplying, we are supplying to the cabin. Okay, so when we supply it to the cabin or cockpit, okay, what happens? Its temperature increases because the air which is supplied to the cabin, it abstract the heat from the cabin. Okay, as a result, that air gets heated. Okay, so this T5 gets heated to T6. Obviously T6, it is greater than T5 because air gets heated in the cabin. Okay, because it absorbs the heat. Okay, so as you can see, this 5, okay, 5 or 5 dash, 5 dash is the actual, 5 is ideal. Okay, so from 5 to 6, what happens? Okay, we are supplying that, okay, into the cabin. So you can see here 5 to 6, 5 to 6 process, 5 to 6, where it is supplied, it is in the cabin. So 5, okay, is the inlet to the cabin, 6 is the exit to the cabin. Okay, so at the exit, we are always getting heated air as compared to the inlet. Okay, so T5 dash is the inlet to the cabin, T6 is the exit to the cabin. Obviously at the exit, the air gets heated. Okay, because what happens with the air, it abstracts the heat from the cabin. As a result, it gets heated. Yes, yes, all of you, is that okay? Yeah. Is that okay with this one? Yes, is that okay?
Okay, sir.
Okay.
Okay.
Now see, so this is all about what we have seen is a simple
TS
air cooling
diagram.
system. Okay, for which we have seen the schematic diagram. Okay, at the same time, okay, we also seen the TS diagram for simple air cooling system. So this is all about the schematic diagram and the TS diagram. Okay, for the simple air cooling system, for the simple air cooling system. Okay, now let us see. Okay, a schematic diagram for the simple air evaporative system. Okay, try to understand simple air evaporative cooling system. Okay, and now let us see this diagram.
तो ये भी सेम ही है उसकी तरह.
Yeah, just see this. Okay, just see this, all of you, this simple air evaporative cooling system. Okay, can anybody let me know what difference you observed between the previous diagram and this diagram? Yes.
So इसमें एक और ये क्या बोलते हैं evaporator
Yeah.
extra है ना.
Yes, exactly. See, all of you see why it is called as air evaporative system, because when you see this part, okay, this additional component they have placed, okay, what they are called as evaporator. Okay, so that is the reason why this system is called as evaporative. That is the reason why it is called as evaporative cooling system. Okay, so that is the reason why it is called as evaporative cooling system. Now what happens, all of you see here. Okay, let us start with that. Okay, this is the inlet. Okay, this is the inlet. Okay, so from inlet the air gets rammed, so we'll get point number 2. Okay, so 1 is the ambient condition from where it is get rammed. Okay, so we will get point number 2. So from point number 2, it is compressed, okay, in a compressor. Okay, it is compressed in a compressor. So we will get point number 3 here. Okay, so from point number 3, some air is supplied to the gas turbine. Okay, maximum air is supplied to the heat exchanger. Okay, so outlet of the compressor, it is nothing but inlet to the heat exchanger. Okay, so air here, the air will flow like this. You can see the air will flow like this, right? Same diagram we have. Once it is coming into the heat exchanger, what happens? Okay, see this heat exchange, this air is going to exchange the heat with this cold air. Okay, now see all of you, if you want, I'll
So
just,
hot air again under.
yes, see here the temperature is T1, here temperature is T2. Obviously T2 is greater than T1. Obviously T2 is greater than T1. Okay, obviously, see, this is possible. T2 is greater than T1. Why T2 is greater than T1? Okay, because it is rammed, right? Similarly, when it is compressed, what will happen? We will get temperature T3 greater than T2. Okay, we'll get the temperature T3 greater than T2 because it is compressed. So temperature after the compression, it is always greater than temperature before compression. Okay, now what happens? Now once we supply it to the heat exchanger, okay, now when you see this T3, it is higher. Okay, so we have here hot air. Okay, we have the hot air here. Okay, this hot air, it is flowing through this tube. Same diagram we have, it is flowing through the tube, and when this hot air, it comes in contact with the cold air, okay, which is flowing on the tube. Okay, what happens, as I already said, okay, this cold air turns out to be hot air. Okay, so this cold air turns out to be hot air. Okay, and this hot air turn out to be cold air here. Okay, so it will turn out to be cold air. Is that okay? Yes, till this, is that okay? Yes, is that okay with this one?
Yes, yes,
Okay,
yes.
so see, what previously we used to do is that cold air we used to directly supply to the turbine. Okay, in simple air cooling system, we directly used to supply it to the turbine. Okay, as you can see now. Okay, we directly used to supply it to the turbine. Now here, okay, what we are supplying it, we are supplying it, okay, to the evaporator. What we are doing, okay, we are supplying it to the evaporator. Okay, so it will flow through the evaporator. You can see this, it is going to flow through the evaporator. Okay, yes, it will flow through the evaporator. So what will happen? Can anybody let me know what will happen through that? Right, see, evaporator, you need not to get confused. Okay, that air gets evaporated. See, air will not be get evaporated. Try to understand, this air will not be get evaporated. The air which is flowing, you try to understand, the air which is flowing through the tube, okay, it will evaporate the water which is present inside. Is that okay, all of you? So whatever the water that is present inside, okay, it's get evaporated due to the what? Due to the air which is flowing through the tube. Is that okay? Yes, because see, this air will be having certain temperature. Okay, and when the air is flowing through this tube, okay, it will evaporate it, okay, the surrounding water, okay, which is present in the evaporator. Okay, so the surrounding water, okay, will be at a certain temperature. The cold air which is flowing through this tube, okay, it will evaporate that water, so that the water vapor will comes out. Yes, and what will happen once it is coming out of the evaporator? Okay, we will supply that to the turbine. Okay, so see here, one more point I need to add. So 3 is the inlet to the heat exchanger. Okay, so here the point number 4 is the exit to the heat exchanger, right? So 4 is the exit of the heat exchanger. It is nothing but what? Inlet to the evaporator. Okay, and 5 is now the exit of the evaporator. 4 is the inlet of the evaporator. 5 is the exit of the evaporator. Okay, now from the evaporator we will supply that to the turbine. we will supply that to the turbine. So what happens? Okay, what happens when you supply it to the turbine? Again, it undergoes the expansion. Okay, so at the exit, okay, let us take the point as 6. So at the exit, see, 5 is the inlet to the turbine, 6 is the exit of the turbine. What we'll get? See, all of you, if you want, I'll just write down here. We'll get temperature at point number 4 less than temperature at point number 3. See, T4, during 3 to 4, cooling occurs in heat exchanger. Where the cooling occurs? It occurs in a heat exchanger. So what happens? This T3 got decreased to T4. You can see this T3 got decreased to T4. So this T4 is less than T3. Similarly here again, what happens? You will get the value of T5 less than T4. T5 you will get it less than T4. Okay, see this T4, it is further decreased to T5. This T4, see, initially it was T3. T3 got decreased to T4 in the heat exchanger. Similarly, T4 got decreased to T5 in the evaporator, because the air which is flowing, okay, it will evaporate the water surrounding. Okay, so when it evaporates, that means what? It will lose the heat, and when it will lose the heat, what will happen? Its temperature will decrease. So we'll get T5 less than T4. Right, now see, now this cold air we will further supply to the turbine. Okay, so the turbine will expand. So as a result, what we'll get? We will get T6 less than T5. Okay, we will get the temperature at the exit of the turbine, T6 less than temperature at the inlet to the turbine. Right, is that okay? Yes, all of you, let me know. Yes, is that okay or not? Yes, is it okay?
Okay, sir. Okay.
Okay, now see, once it is coming out of the turbine, that is point number 6, we are supplying it to what? We are supplying it to the cabin. Okay, so after the cabin, it will comes out at point number 7. Try to understand. See, after it is getting out of the turbine, we will supply it to the cabin. Okay, so point number 6 is the exit of the turbine, or it is nothing but inlet to the cabin. Okay, and 7 is outlet of the cabin. So what you will observe that temperature at point number 7 is greater than temperature at point number 6.
7.
Yes, because what happens when you supply the cold air into the cabin? What will happen? Okay, the cold air will abstract the heat from the cabin. The cold air will abstract the heat from the cabin. As a result, its temperature increases. Okay, so temperature of the air increases. Okay, but what happens with the cabin temperature? It decreases, because the air has abstracted the heat from the cabin. As a result, temperature of the cabin decreases. What happens with the temperature of the air? It is increases. It is increased to T7. Okay, so this is how this schematic diagram, okay, operates, okay, for simple air evaporative cooling system. Okay, so see, one component we added, that is evaporator. Okay, but don't get confused with the name evaporator. Okay, what happens? This hot air which is flowing, see this cold air which is flowing through the tube. Okay, it will further evaporate the surrounding water. Okay, see, all of you, it will evaporate the surrounding water. Okay, as a result, what happens? Its temperature decreases. Okay, temperature of the cold air further decreases. What happens with the temperature of the water? It increases, and further this water, okay, gets converted to vapor. Okay, so is that okay? Yes. Yeah, is that okay with this one? Yeah, is that okay with this one? All of you? Yes.
Yes, sir.
Okay, now let us see the TS diagram. Okay, see this one, you know that this is the ambient condition. One we used to call it as ambient condition or inlet conditions. Okay, this is the ambient condition, right? So from 1 to 2 we will ram it. Okay, so this 1 to 2, as we know, it's the ideal process. Okay, this 1 to 2 dash, okay, it's the actual process. 1 to 2 dash, okay, it's the actual process. As you can see, this 1 to 2 dash is the actual process. Okay, now once it is ramped, okay, we will supply where? We will supply it to the compressor. So this 2 dash, okay, it is nothing but inlet to the compressor. Inlet to the compressor. So compressor will compress it. Okay, so it will compress from 2 dash to 3. So 2 dash to 3, it's again an ideal compression. Okay, while 2 dash to 3 dash is again an actual compression. I already told you the difference between ideal and actual. For ideal we have efficiency 100%. Okay, for actual we have efficiency less than 100%. Okay, now once it is getting out of the compressor, where we will supply? We will supply to the, where you can see this 3 dash to 4. Okay, where will supply? We will supply that. Okay, to what? We will supply that to the heat exchanger. See all of you, 3 dash to 4. Okay, 3 dash to 4, you can see this 3 dash to 4, 3 dash. See, if you want, I'll just write down 3 or 3 dash. They are exit of the compressor. See these 2 points, 3 and 3 dash, they are exit of the compressor. They are exit of the compressor, right? Exit of the compressor, it is nothing but what? Inlet to the heat exchanger. Inlet to the heat exchanger, right? Inlet to the heat exchanger, right? So once it is coming out, see, once it is coming out of the compressor, we are supplied to the heat exchanger. So point number 3 is the inlet to the heat exchanger. So point number 4 we will get, okay, that is nothing but outlet to the heat exchanger, right? We'll get it as outlet to the heat exchanger, right? We'll get it as outlet to the heat exchanger, right? 4 is the outlet to the heat exchanger, right? Now see all of you, why they have mentioned it as a 4 dash. Okay, so they haven't taken 5 as a different point. Okay, so simply they have called 4, this point as a 4 dash. So if you want, I will also make it like this, 4 to 4 dash. Okay, then 4 dash to 5 and 5 to 6. Okay, so only this thing we need to change. Okay, T4 dash I need to make, T4 dash. Okay, then this 5, T5 is less than T4 dash. Okay, only those things I will change. Okay, and this T6 is less than T5. Right? Is that okay?
T7,
Yeah.
T5.
Yes. Okay, so here all of you. So 4, point number 4, it's the outlet to the heat exchanger, or outlet to the heat exchanger, it is nothing but inlet to the evaporator, right? Inlet to the evaporator. Yeah. So this point number 4 is the outlet to the heat exchanger, or it is inlet to the evaporator. Now what is 4 dash? Okay, it is nothing but outlet of evaporator. It's the outlet of evaporator, right? So 4 dash is the outlet of evaporator. From the evaporator, where we are supplying? We are supplying it to the turbine. Okay, so outlet of the evaporator, it is nothing but inlet to the turbine, right? It is the inlet to the turbine. Okay, 4 dash is the inlet to the turbine. 5 is the exit to the turbine, right? It's the exit to the turbine, right? 5 is the exit to the turbine, right? Okay, now once it is getting out of the turbine, okay, where will supply? Okay, now again here there are 2 possibilities, 4 to 5 dash. 4 to 5, 4 to 5, it's the ideal. Okay, but when you move from 4 dash to 5 dash, okay, it's a actual. See, 4 dash to 5, it's ideal. 4 dash to 5 dash, it's a actual. Okay, now once it is getting at point number 5 dash, where will supply? Okay, we will supply it to the cabin. You can see this. Okay, this 5 is inlet to the cabin, 6 is the exit to the cabin. Okay, so this point number, exit to the cabin, exit to the turbine, it is nothing but inlet to the cabin. Exit to the turbine, it is nothing but inlet to the cabin. Okay, and what is 6? It exit to the cabin. It is the exit to the cabin. Is that okay? All of you see here, all of you see every point I have plotted there. Yes, is that okay?
Okay.
Have you understood this diagram?
Yes.
All of you, how this cycle works? Okay, 1 to 2 is a ramming, 2 dash to 3, okay, or 2 dash to 3 dash, it's a isentropic compression in a compressor. 3 dash to 4, okay, it is a heat rejection in heat exchanger. 4 to 4 dash, it is heat rejection in evaporator. 4 dash to 5, it's isentropic compression. Okay, 4 dash to 5, it's isentropic compression. Yes. Okay, 4 dash to 5, as you can see, it's isentropic compression. Okay, then 5 dash to 6, okay, it is cooling in cabin. Okay, so 5 dash to 6 will give you the cooling in cabin. Yes, is that okay with this one? Have you understood how the cycle works?
Okay, okay.
Yeah, is there any doubt you are facing with this one?
No.
Yes, is there any doubt you are facing? Yes, are you facing any doubt as far as what we have taken today?
No, sir.
Okay, so with this, okay, we will conclude the today's session. Okay, and in the next session we will see the analysis of these cycles. Okay, we will see the derivation, okay, for the analysis of these cycles.